All right, let's do a carbon dating problem, one more carbon dating problem. So let's say we know that redwood trees, living redwood trees, have 0.04 nanograms of carbon-14 per gram or per kilogram or something like that. We find an old piece of redwood that has 0.0048 nanograms of carbon-14 in it. How long ago did this redwood die? So to figure that out, we use the carbon dating equation. Where this is the amount, in the object we have. This is the amount in a living object times, this is multiply, 2 raised to the t divided by the half-life power. So this is the exponent, and it's going to be the time since it died divided by the half-life. And in this particular case, it's carbon-14. So we know the half-life there is going to be 5,730 years. You do need a negative with it to make it decay. So it's got to go away, get smaller. So this thing will be smaller than this number. So we found the amount we have is 0.0048 nanograms. Normal is 0.04. This is in a living redwood. And then times 2. We don't know the time. That's what we're figuring out. We're going to divide it by negative 5730. So that's our starting equation. This amount decayed away to this amount in this amount of time. All right, start by getting the base and the exponent by itself. So I want to get rid of this 0.04. I divide both sides by 0.04. So 0.0048 divided by 0.04 is 0.12. So we're down to 12% of what we started with. Leave a space on this side, leave a space in here. So equals 2 raised to the t divided by negative 5730 years, okay? Now, when you have the base and the exponent by itself, you can take the log of both sides and bring that exponent down in front. Draw yourself a little arrow there to remind yourself that that's coming down in front. The whole exponent comes down in front. The calculations are only over here on the left side, so I just do ln equals, I already have 0.12 in there, never hit clear. Negative 2.12 is the ln of 0.12. You can use log if you like. ln or log are the same. Just make sure you do the same on both sides of the equation. Over here I have t over negative 5730 times ln of 2. So that exponent came down in front, now is multiplied times ln 2, and there's no exponent with the 2 anymore. Now I want to get the t by itself, so I need to get rid of 30 and the ln 2. Doesn't matter how you do it. Let me get rid of the ln 2 first. Divide both sides by ln 2. So I just go divided by ln 2 on my calculator. I don't have to calculate what it is, just divide by ln 2. And that equals negative 306. Negative 3.06. So I'm not rounding because I never hit clear on my calculator. On the right side, I've got t divided by negative 5730. The ln 2's gone. Now to finish the problem, I just have to get rid of that negative 5730. So I multiply both sides by 5730. T is divided by 5730. I do the opposite of dividing. I multiply, and that cancels it out. I have to do the same thing over here, multiply by negative 5730. And I still have that negative 305 on my calculator, so I just go net times negative 5730. So just multiply times negative 5730, and I get 17,527. So 17,527 years. And that's our answer. So check that, go slow, practice.